Welcome to The Explainer. Ever wonder how data scientists take these massive, messy data sets and somehow turn them into these beautiful, insightful visualizations? Well, today we're going to pull back the curtain and build that exact data analysis toolkit right here in Python from the ground up. We're going to see how three powerhouse libraries, NumPy, pandas, and matplotlib, work together to form the very backbone of scientific computing.
Okay, let's dive right in. Think of today as a four-part journey. We're going to start with the absolute bedrock, NumPy, which is really the engine that powers everything else. Then, we'll build on top of that with pandas to see how we can give our data some much-needed structure. After that, we'll unlock the secret to blazing fast performance with something called vectorization. And finally, we'll put it all together and bring our data to life with some amazing visuals using matplotlib.
All right, first up, let's meet the unsung hero of the Python data science world, NumPy. This library, which is short for numerical Python, is the engine that drives pretty much all scientific computing you'll ever do in Python.
You know, this slide just captures it perfectly. Think of the Python data science world as a giant skyscraper. NumPy is the concrete foundation. It's not the flashy part you see from the outside, but it is absolutely what supports everything else. You can see right here how critical libraries for statistics like pandas or machine learning like scikit-learn, they're all built directly on top of NumPy's powerful array capabilities.
So, at the very heart of NumPy, the thing that makes it all tick is its core data structure, the ND array. That just stands for n-dimensional array. Imagine a spreadsheet, but on steroids. It's a super efficient grid of values that's built for one thing: high-speed numerical calculations. And here's the golden rule, the thing that makes it so fast. Every single element inside an array has to be the same data type. That's the secret sauce.
To really get why this is such a game changer, let's use a little analogy. A regular Python list, that's kind of like a shopping bag. You can just toss anything you want in there. An apple, a book, your keys, whatever. It's flexible for sure, but it's not optimized for number crunching. A NumPy array, on the other hand, is like an egg carton. It's rigid, it only holds one type of thing, eggs, and it stores them all packed together in a single unbroken block of memory. That's what contiguous means. And that organized structure is what lets your computer just fly through calculations.
And making one is super simple. Right here, we're just taking a basic Python list of lists and turning it into a 2D NumPy array with employee names. I mean, it works, but let's be real. This raw data is kind of a pain to look at, right? We have rows and columns, sure, but we don't have any labels to tell us what they actually mean. And that's where our next tool comes into play.
And this, my friends, is where the magic really starts to happen. Enter pandas. Now, pandas doesn't replace NumPy, it makes it better. It gives you this beautiful, intuitive structure right on top of NumPy's raw computational power.
So here's the most important thing to understand. Pandas is built on top of NumPy. They are designed to work together perfectly. Pandas takes those powerful ND arrays we just talked about and gives them context. It turns them into the object you'll spend most of your time with as a data analyst, the data frame.
With just a single line of code, look at this, we can pass our employees' NumPy array directly into pandas. And here's the cool part. We also give it this columns argument, which lets us assign a meaningful name to each column. It's really that easy. And boom, here's the result. It's the same data underneath, but now it's in this clean, labeled table. We have a nice index on the left, our custom column names up top. This data frame is just so much easier to read, to understand, and to work with than that raw array we started with. You can see how this is a total game changer, right?
Okay, so now we have our data all neat and structured in a data frame. But how do we actually perform calculations on it really fast? Well, that brings us to the secret weapon in our data analysis toolkit, vectorization.
So a super common thing you'll need to do is create a new column based on values in other columns. You know, like calculating profit by subtracting cost from revenue. The first way you'd probably think to do this is to just loop through the data frame one painful row at a time. But in pandas, that is incredibly inefficient. So what's the faster way?
Let's just compare two approaches side by side. On the left, we've got the .apply method. This is basically a Python loop running over each row. Think of it like a cashier, checking out customers one by one. It gets the job done, but it's slow. Now, on the right, we have a vectorized operation using a NumPy function. This is like having a self-checkout lane for every single customer. They all get to scan their items at the exact same time. It's not looking at one row at a time, it's operating on the entire A and B columns all at once.
And the difference in performance is, well, it's just mind-blowing. Take a look at this table.
For 1,000,000 rows, the .apply method takes a full 24 seconds. The vectorized NumPy way? Less than a second. It's over before you can blink. But now let's scale it up. At 10,000,000 rows, the looping method takes 262 seconds. That's over 4 minutes. Go make a coffee. The vectorized way? 4 seconds. This isn't a small tweak. It's a fundamental change. We're talking about something that's over 65 times faster. That's not an improvement. That's a rocket launch. So that is the power of vectorization. Instead of your code acting like a teacher calling on each student one by one, it's like the teacher gives one single command and the entire class does it all at once. What you're doing is bypassing those slow Python loops and tapping directly into the highly optimized precompiled C code that makes NumPy so fast. It's like you're speaking the computer's native language. Modern processors are built for this, to do one instruction on many pieces of data at once. Vectorization just lets you take advantage of that.
All right, so we've got our data nicely structured, and we know how to run calculations on it at lightning speed. But what good is all that data if we can't actually see the story it's trying to tell us? The final piece of the puzzle, the big payoff, is turning all that processed data into real insight through visualization. And that's where the wonderful world of matplotlib comes in.
You know, the absolute best part about this whole Python stack is how seamlessly everything works together. You don't have to export your data or reformat it. You can literally call plotting functions directly from your pandas data frame, and under the hood, it'll use matplotlib to draw the charts. So for example, let's say we want to create one single image that shows performance trends for different product groups, each in its own little chart.
So how do we do that? How do we make one big picture with a bunch of smaller plots inside? It's a pretty simple 4-step process. First, we use matplotlib to set up a grid of empty canvases, or what it calls axes. Then, we use a super powerful pandas method called groupby. This splits our whole data frame into smaller chunks based on a category we pick, kind of like splitting a deck of cards by suit. And finally, we just loop through those smaller groups and tell each one exactly which empty canvas to draw its chart on.
This little snippet of code right here, this is where that amazing integration really shines. We're using Python's zip function to walk through our pandas groups and our matplotlib axes at the same time, in perfect sync. In every step of the loop, grep is the data for one group, and ax is one of our empty plot areas. And that last bit, grep1.plot ax equals ax, is the command. It's literally saying, hey data group, I want you to draw your plot on this specific canvas. It's just a beautiful dance between data and visualization. So let's just zoom out and look at the big picture here. This is your complete end-to-end workflow. Each one of these tools plays a specific, critical role, and it builds on the one before it. It's the data science dream team. You use NumPy for the raw speed. You use pandas to give that data structure and meaning. You use vectorized NumPy operations to get your calculations done in a flash, and then you use matplotlib to actually see the results of all your hard work.
This whole process, from a raw array to a structured data frame to a high-speed calculation, and finally to an insightful visualization, this is the absolute backbone of data analysis in Python. You now have the keys to unlock the stories that are hiding inside your data. The only question left is, what are you going to build with it? The possibilities are pretty much endless.